the infamous topic within JavaScript, closure. So let's discuss what this is and give you an example of how it works. So a closure occurs when you return a function from another function, and the function that you return from that other function maintains reference to its lexical environment. Now, if none of that makes sense to you, let me explain this by example, as I think that makes a lot more sense when we do that. So what I've got going on here is I have an outer function right here. And in the body of this outer function, I define one variable here called count, and I assign it or initialize it to the value of 0. And then I return a function from my outer function. And what do I return? I return another function. And if this is your first time learning about closures, I understand that this is not the most straightforward thing to reason about. But I return an inner function. And what this inner function does is it first console logs my count, and then it just increments the count. And what's going to happen here is when I call this outer function, it's going to create its own kind of execution context for the body of its function here, and it's going to return this inner function. Now, once it returns this inner function, this outer function, it's going to close. It's going to stop running. And when a function closes and stops running and is popped off the call stack, well, usually all of the kind of execution context for that function is garbage collected and removed. But since this inner function references a value within this outer function here, within its lexical scope is where something is written. So this inner function is going to remember and is going to retain access to all the data within where it's written, its lexical scope. So since this inner function references something in its lexical scope here, where it was written, even when this outer function closes, this inner function is going to maintain reference to this data. And that is called a closure. So even after this outer function kind of closes, this inner function is going to still be able to use this data here. So here on line 18, I create a constant called counter function, and I assign that to the return value of calling my outer function. And when I call this outer function, it's going to initialize this count to 0, and it's going to return my inner function right here. So this counter function here is going to be my inner function. And when I call this counter function 3 times, you're going to see that it's going to maintain reference to this count variable, and it's going to increment it as you would expect. So here I get 0, 1, and 2 because it maintains reference to its lexical scope here, to this closed over variable. And this will be true for every instance of my inner function here. So if I create another function called counter function 2, and I call my outer function again, well, that's going to return a completely new inner function that is going to have its very own execution context and its very own count variable. The count variable within this counter2 function, it's not going to know anything about the count variable from my first function right here, just my counter function. So if I call this function 3 times here, what do you think is going to happen? Well, since this counter function, it's going to have its own execution context, and its count is going to be completely independent from this counter function's count. It's going to be the same thing. I would expect to get 0, 1, 2, 0, 1, 2. And that is exactly what is console logged to my console here. Okay, so a closure occurs when you return a function from another function, and that returned out function maintains reference to all the data within its lexical scope where that function was written. It still gets to access all that data even after that outer function has closed and has popped off the call stack.